Hello everyone. So this is day 49 and we are going to discuss the logistic regression. So in the last session we have seen how to implement linear regression and what is linear regression, and also how to calculate the equation y equal to mx plus c. So that was a manual approach. So all these models, whatever we are learning during this Alteryx session, so those are manual models. We are not using, so in the Alteryx, the solution which we are creating, that's a normal way to achieve this logistic regression or linear regression. But yes, there are, when you are working in enterprise based solution for Alteryx, so Alteryx is providing, so that's a license tool. So you will be having all these model component. So instead of writing all these formulas and everything, you can simply drag and drop and connect with the data, and it automatically works. The algorithm in the backend, it automatically works. So, but yes, I mean, in the mostly the project, we don't use these things, but I'm just explaining you guys how we can do this in Alteryx as well. Mostly our job is like as a ETL developer or data engineer. So our job is to connect the data sources, transform the data, prepare a clean data, and load the data to any server or location. That is the objective of Alteryx as well. So that's Alteryx is a ETL tool that is used to extract, transform, and load the data. But these are the also things which can be achievable in Alteryx. So Alteryx has given a capabilities to all these things to be done directly in Alteryx environment. Instead, you go and write some formula in Python, or you use some extra solutions, right? So Alteryx is providing this inbuilt. So when we are working in enterprise model or enterprise architecture, when you are working on a live projects, so there you will be having a different kind of license. So which you can, this is a learning license. So if we don't have all the things, all the components, we can use some of the basic components, and all those components related to R tool and Python is there. So this logistic regression and all these things, you can find those things in that tool, right? So but here you can explore, like, I mean, there is nothing like too much of tools are not given or components, but still this is also enough to understand, like, yes, we can do something like this, and we can connect with the data sources, and we can bring the data sources, and we use database reporting. All these things we have used it, right? So these are the basic things which we are using it. And if you're visiting to this channel first time, so please like, subscribe, comment, share your feedback as well. And if there is any topic you wanted to discuss, please feel free to write in the comment section. I'll be happy to help you. So let's jump into like what exactly is logistic regression in mathematical uh, function, right? So the goal is, if you see, the project goal was to understand, this is a very sample data which I am using: customer ID, monthly fee, tenure, month, support calls, and churn. This is a target. So I am setting a source as well. I am giving a target as well. So the goal is to understand how many times the target and the predicted columns are matching using Alteryx. Okay. Now let's jump into the project. Like, what is logistic regression? Is a supervised learning algorithm for binary classification. So what we do, like, unlike linear regression where predicts the continuous number, like for example price or revenue, logistic regression will predict the probability that an input belongs to a specific category. For example, churn versus not churn. So whether that customer is out from the market or in the market, or that particular customer is buying the product or not. So the output will be always between 0 and 1, right? And this is a logistic regression formula, so like, which is using the linear base and the calculation. And let's go into like what are the use cases we can do using this tool. So we can use this to in retail predict which customer will cancel their subscription. Finance, credit risk model, so whether you are identifying like whether the loan applicant is eligible to get a loan or not. Healthcare, like disease screening, whether you wanted to understand like whether the patient is in high risk or low risk, what is the age and the symptoms. Manufacturing, if the machine will fail within next 24 hours or 48 hours, depends on like the kind of project we are working. And e-commerce, like trying to understand the conversion prediction, like conversion, like if I'm going to a store, so if I'm buying some product, so we need to understand, they would like to understand whether this customer will visit to this store again or not, or that customer will buy that product again or not. That is the objective. Now the algorithm, so here if you see, the formulas are not too much clear, the logistic regression formula, but we can just Google it here, logistic regression, what exactly it is this and the formulas. So logistic regression, again, it is a statistical model, right? We understand that. So you don't have to go in depth. You need to understand the basics, like, okay, what is, if you are coming from a data science background, so obviously you will know what is logistic regression and what is the problem statement we can use to logistic regression with one explanatory variable and two categories to answer the following question. So like a group of 20 students spend between 0 to 6 hours studying for an exam. How does the number of hours spent studying affect the probability of the student passing the exam? So if the group of these students are studying like 6 hours for one exam, so we would like to understand like what is the possibility, what is the probability of passing those exams, right? So there are some formulas which is here in the PDF file, it is not correct. So if you see here, this is the logistic function px equal to 1 divided by 1 plus e, where you are calculating like location parameter, scale parameter, and some of the other things as well, like likelihood estimation, so which sigmoid function, right? So mathematics of logistic sigmoid transformation to ensure the output of the probability is 0 to 1. So this is just an idea about, or a general idea about the logistic regression. Now, there are a lot of blogs online we can find out, and we can just go and check like why use logistic regression instead of linear model, right? So that will also, you can go and watch this blogs or go through these blogs and try to understand. And if there is, definitely if there is any questions or query, I can help you in that. So let's jump into our workflow, what we created. So customer ID is this, and then let me run this entire workflow first. So this is just getting the data first thing. So that is like 100 of records. That's not a much record, but yes, I mean, you can ingest million of rows. So where, and what kind of data set? So when we are working in a logistic regression, so we need to understand also like, so what we are trying to understand here, goal, the support calls and the churn target. So whether this customer will call again or not, or how much calls these customers are calling and what is the probability in future. So we are setting a target also when we are working in a logistic regression, so that when we predict the value, the final value, so we can compare like whatever the budget was there. For example, when we are working in a finance, I'm giving one simple example. So there is an actual budget and predicted. Now, based on budget or target, like you have a target, so you need to achieve 300 sales. Out of 300, you achieved only 290 or 250 or 275, 245. It could be any number, right? But you set the target. Now, based on the target, you predicted the value, like what is the probability of whether this target will be, we will be able to achieve it or not from the market, right? So these are used mostly, these regression and models are used in business cases, those were like e-commerce, finance, credit risk modeling, loan. So in those, or even supply, that can be any project which you are working. And we can also use these use cases for our projects, like day to day in our work, whatever we are doing in Alteryx or in any tool, like if we are working in any some other tool, so that also we can check it. Okay. Now let's jump into what we are doing. So first we are bringing the data, that is the objective, then summary. So here what we are doing, we are calculating the minimum fees, maximum fees, minimum tenure. Maximum tenure is this. Minimum support calls is 0, maximum support calls. So max to max, those customers are calling 5 times to the call center. And this is like a call center data. Okay. So where the BPU is trying to understand, like for each customer, what is the monthly fee they are it is impacting, and what is the tenure month in 12 months or 48 months, how many times that customer has called, and what were the support calls, like it is 1 time, 5 times. So if you see here the row number 2, so this customer has like called to in 2 months, this customer has called like 5 times and the churn target is 1. So that means like there is an issue, right? So in 2 months, the customer has called 5 times, so his issue is not yet resolved. That is the idea of the data. Like by looking to the data, we can see. So that is what, and on top of this churn, we will be predicting like whether this is matching, the support calls are matching, or the churn target is matching to the actual predicted value or not. That is what we are trying to achieve. So we got everything, minimum, maximum, all these things we have got. And then we are appending the final this one to the target of the with the input tool. So what we appending means we are just joining, merging the one output with the another output, so that we can get like, okay, this customer monthly fees is this, support call is this, minimum tenure was this, maximum tenure was this. Maximum tenure mostly for every customer, if you see, it is 48. Minimum support is 0, maximum is 5. But from 5, you cannot call more than 5. Now here I am doing some calculations. So what we are trying to calculate, like we are trying to understand what is the nominal fee, like monthly fee minus minimum fee divided by maximum minus monthly fee. Then normal calls and the normal tenure. So that is what we are trying to achieve here. So what will be the nominal fee or normal calls or minimum tenure or normal tenure of a customer. So if you want to aggregate like, okay, out of 12 months, this is the normal times customer has called, like out of 48, the customer has called 12 times, maybe within 2 months. So then there is a issue. If customer is not calling or 0 calls are there, then there is no issue. Or maybe the customer has called once and the issue has been sorted out. So that is what we are calculating using these formulas. And these are like business logic, so which I have worked in a lot of projects, which I am giving an idea, like the projects which I have worked on, those use cases I am bringing it to here, so that you can also understand, like, and you can leverage these ideas in projects as well in your resume. And after that, I am trying to calculate like churn probability. So there are a lot of ways to calculate churn probability. Okay, so let me just uh, calculation. So if you see the formula, like churn prediction, so there are a lot of different ways to calculate churn, like in financial impact, customer behavior. So every customer, like NPS calculation, what is the formula? So churn probability, let me just search formula. So how to calculate the churn rate, right? So if you see here, they have given what is customer churn rate and how you will calculate. So there are a lot of tools in the market as well, like how you can calculate. So predicting, prioritizing customer success. This is what we are trying to understand here. So whether the so how the lost customer divided by. So every churn formula could be different. Okay, it is not like there is a straight away a square plus b square plus 2ab. Some formula is there which we can implement, right? So every churn rate has a different. If you see churn rate formula, so total number of customer lost during period, then total number of customer is started, and then churn rate is getting calculated in a different way. So every business has a different way to calculate this churn rate. Okay, so what I'm doing here, I'm just calculating the probability, then, and this is the formula which I'm using. So normal calls, I'm just giving 0.5 because the minimum, and tenure 0.3, and the nominal fee is 0.2, and then the data type is double. Okay, So this is getting me the churn probability. So I can understand, okay, this is the probability that customer might call this much time. Now again, I'm predicting the churn. So if it is greater than 0.5, then 1 or else 0. So I got this 0 and 1. And now again, I'm summarizing this. So I just wanted to see like the predicted churn and the target churn. So what is the output is telling me? So the output is telling me the churn target was 0. This count is a customer ID count. So this is matching 20 customer to 20. So the target was 0, predicted is also 0. 35, this is target was 1 for 35 customer, but the predicted is 0. Now why predicted is 0? Based on the logic. So based on different logic, it can be 0. So we need to figure it out like why the target was set 1. Now I'm predicting 0. So I need to go and check those 35 customer. Now this is also a focus area and this is also focus area. The predicted was for 18 customer, it was 0, but we got 1 because their probability is greater than 0.5, right? Based on the nominal tenure, nominal fee, and all these things, all these logics. And then on top of it, also this is matching, this is matching. So for the first and the fourth is fine. But the second and the third one has to be looked. So whether we have predicted that target should be 1, so at least the customer will call once, but the predicted was 0. So that means whether the data is incorrect or like the customer has called, but the predicted value, there is something wrong in the logic and it is giving me incorrect value. That should be the one case. Second thing is like the 18. So the predicted churn target, the churn target was 0, set it up 0. So we assume the business assumed like 30, 18 customer will never call back. But we got as per their minimum fee, maximum fee, and all this using the logics, we got one. So we need to focus what was the issue. So the second and third both are issues. So business will take a decision on that and they might go and fix the data either, or they look into the fee, or they look into the tenure month or the support calls, right? And this is getting, if you see here, so if it is 4, there is a, if it is 2, then also it is 0, 5 it is 1, 4 it is 0. So these are randomly generated numbers, but it is possible like the data is not correct. That is one thing. Also, after looking to the final output, another thing has to be fixed here by looking to the data, maybe the monthly fee and the tenure and all these things, support calls and churn target. So based on what logic you are creating support calls, based on what logic. So those things we are not using, right? We got this 4 rows of data and based on that I just put some random and then it is calculating the prediction. But yes, I mean, the idea of the logic was to understand, the goal was to understand the target is matching with the predicted number or not. One, it apple is matching to apple or not. So here what is happening, apple to apple, apple to apple. But here apple to orange, orange to apple. This is what happening. So we need to focus, the business will focus on this to these 2 rows, like 35 and plus 18 customers. So almost like 53 customers, they will be focusing like what is the issue that we predicted the churn should be 1, but the target should be 1, but the predicted value is coming 0. So either the nominal fee is not correct, monthly fee or the tenure one. So we need to fix that and run the model again and then recheck the output. So that can be done. But yes, I mean, this is how we can achieve. And these are basic mathematical approach, not complex. We are not doing anything. I'm not doing anything complex here, but yes, it's just a minimum, maximum I'm calculating. And based on some of my here normal tenure, I'm calculating 1 minus the tenure months. And then I'm dividing, subtracting the minimum tenure. And then I'm dividing with the maximum tenure minus minimum tenure. So I'm trying to calculate the what should be the normal tenure for each customer. What should be the normal calls for each customer? What should be the normal fee of each customer? And based on that, we are calculating the probability and then we are predicting the churn. So if it is this is a unique formula. This will not change. You might have to go and check the data or correct the data or make the changes to the data. So you can come back and rerun this model again and check the output, like whether this output is matching to the value or not, right? So yes, this is about the logistic regression in Alteryx, like how we can achieve it. So thank you very much for watching this video and stay tuned. Like, subscribe, comment, share your feedback, and let me know if there is any specific topic or something you want to discuss related to Alteryx, or you are already started working in Alteryx, or if you are watching this video first time, so please go and watch the previous videos and let me know if there is any question related to those videos, or if you are struggling to create some workflow in enterprise solution. So you can mention in the comment section. I'll be happy to help you guys. So thank you again, and yeah, stay tuned.